Welcome to the channel, everyone. Today, we're tackling one of the most mind-blowing ideas in logic, the completeness theorem for first-order logic. This theorem is a game-changer for math, computer science, and philosophy. Curious about how truth and proof connect? Stick around, we're diving deep. First, let's get on the same page. First-order logic is a system we use to talk about objects and their relationships. It's got quantifiers like for all and there exists, and connectives like and, or, and not. Think of it as the language behind modern mathematics and computer science. For example, we could say for all x, if x is a cat, then x has whiskers. Here px means x is a cat, and qx means x has whiskers. Now in logic, a proof is like a treasure map. It's a sequence of statements where each one follows from the last using rules like modus ponens. If A implies B and A is true, then B must be true. Proofs take us from axioms to conclusions, step by logical step. On the flip side, we have models. A model interprets our logical symbols. It's got a domain, like the natural numbers, and assigns meanings to symbols. For instance, if px means x is even, then there exists an x where psx is true holds because 2 is even. Here's the star of the show, the completeness theorem, proven by Kurt Gödel in 1929. It says, if a formula is true in every possible model, we call that logically valid. Then there's a proof for it in first-order logic. If it's always true, we can prove it. This means our proof system catches every logical truth, no exceptions. Why is this a big deal? It tells us our logical system is rock solid. If we can't prove something, there's a model where it fails, a counterexample. And if it's true everywhere, a proof exists. It's the bridge between what's true and what we can prove. Kurt Gödel, a logic legend, gave us this theorem in 1929. Fun fact, he also proved the incompleteness theorems, showing limits in math. But that's a wild ride for another video. Let's see it in action. Take for all x, px implies px. It's always true, anything implies itself. The completeness theorem says there's a proof, and here's a simple one. Even for trickier stuff, if it's valid, a proof's out there. Time to think. What's a formula that's not always true? Try there exists an x where px is true. True if p fits something in the domain, false if it doesn't. No proof exists in general, it's not logically valid. Pause and share your ideas in the comments. To wrap up, the completeness theorem links truth across all models to provability. It's a cornerstone showing our logical system is complete and powerful. Love this? Hit that subscribe button and tap the bell for more logic, math, and computer science goodies. Drop your thoughts or topic requests in the comments. I'd love to hear from you. See you next time.